graphed one. I'm going to have you for right now graph. We're going to do 2 to the x because that allows me to get a lot of points on there.
You go back to the last page.
No, I can't. I need to move on. You were talking.
I was copying Scott.
Okay, what points did you plot?
0, 1.
On your assignment for today, you should have actually. We can actually do 3 on this one, and we know it went 1, 2, 4, 8. Okay. If I want to graph a logarithm, if I ask you to graph the log base 2, still base 2, what changes? The point switch, because the domain and the range switch places when you do a log. So now you have the 0, 1, 2, 3 in the y column. You switch, and then we have the 1, 2, 4, 8. It just switches places. That's all you do to graph a logarithm. I'm going to put them both on here. The exponential function goes up 2, 4, 8, and I need a horizontal asymptote. Okay. But what does, I need another color. If I graph the logarithm,
Doesn't that have the y?
yeah, Luke, you're right. 1, because when I plot these points, 1, 0, then I would be over 2, up 1, over 4, up 2, 5, 6, 7, 8, 3. So if I connect the dots, I've got a curve, but where else does it need to go? It's not that dead. Yeah. It goes down, and yes, the y-axis is now the asymptote. And together, they look like a hallway. They also look like inverses, because you remember inverses reflect over the line y equals x.
Yeah.
They reflect over the diagonal line. These two are reflected over the diagonal line. So logarithms, where exponential functions grow really, really fast, logarithms grow really slow. Really, really slow. They rise very slowly. And notice, remember we said you always have to have a log of something positive? Notice, this graph only exists over on the positive side. It can flip, but then you've got to have negatives. You have to add negatives to the equation to flip it. But a normal logarithm is always on the positive side. Now, we are going to flip them, yes. They flip and shift just like every other graph we've just done. That doesn't change, ever. So, yes, red is log, yes. So, let's see if you can draw a log. If I said, what's a fun one to draw? So let's draw negative. We'll do a base 3 log, change up the numbers. Okay. The shifting's identical, and you need to always do that first. Does it shift right and left? Does it shift up and down? Okay, are we buying that? She said up 2, right 4. Yeah. That 2 added on the back makes it go up 2. And so that's where your asymptote will be, once you find that point. So right 4 up to, that's our new origin. That's where we're counting from. And yes, we have an asymptote on the y-axis, straight down this baby. Okay, so logarithms have vertical asymptotes. Okay, I threw a negative in this one. Which way is it going to flip? Negatives in front are over the x. So okay, which on logarithms, for some reason, people have trouble seeing how logarithms are going to flip. It just kind of mentally plays with your brain. So if a normal logarithm comes up the y-axis and then curves slowly off to the side, what's it going to look like if you flip it upside down?
It's going to be going down the x-axis and curving.
Yeah. Since this is, well, since it's following the asymptote here, down the y-axis, it's got to be following up the y-axis when you flip it. So this top part that was curving over it has to curve under it.
Look at that. Just look at it.
So it's kind of, I don't know what it is about that flip, but that flip bugs people visually to
Blue and red makes
realize it.
purple.
Yeah, that doesn't make any sense to me. I'm
What?
so confused.
You're going over, this part's below the x-axis. So if you got to flip upside down, if it's going below the x-axis, then this has got to go above the x. This part that's curving above the axis would then have to be curving below the axis. You have to flip over this. You're going around this. So I'm turning it upside down. Okay, now, how do you get the points to plot to do it? That's the real kicker. Okay, you're going to do a t-table, but where are you going to put your 0, 1, 2 on a logarithm?
On the y part.
Yeah, you're going to put the logarithm, you're going to have the 0, 1, 2, 3, actually we're doing a base 3 here, 0, 1, 2. So since your base is 3, you're doing 3 to the 0, 3 to the first, 3 to the second. So yes, I'm going to get 1, 3, 9. So from this point, this says go 1, 0. So you're going, it's going to look like this red one we drew down here on this graph, so I'm going to go, whereas exponential functions always had a point at 0, 1, up 1 from the origin, logarithms always have a point 1 to the horizontally from the origin. So we're going to be over here. Now I got to go 3, 1 from the origin. 1, 2, 3. Now up 1 or down 1?
Down one.
It flips because of the negative, so I'm down 1. There it is. And then if I have 9, 2, 3, 4, 5, 6, 7, 8, 9, down 2. And I'm going to be off my graph paper probably, and so then I'm going to go zooming up that.
Oh, curve away. You curve away.
Sorry, I curved away slightly.
That would probably lose us points. I think you should lose some points.
One that small would not lose you points. One that goes swooping out into the no man's land will get lose.
Okay, so if it's less than. Just saying, it's not a fun.
All right, here we go. Brains in gear. How do I figure out log, without a calculator, how do I do log base 9 of 81? Why is it 2? Yes, because 9 to the second power is 81, and the answer is always the exponent. The answer to a logarithm is the exponent. So, what if I did log base 3 of 81? 3 to what power is 81? Colin wins. 3 to the 4th is 81. So therefore, so the answer is 4.
I get a prize for winning.
You get my undying gratitude.
Yeah, he's gonna bitch.
Okay, what if I gave you log base 6 of 136?
It would be negative.
Negative.
Negative the second, so it would be negative 2.
Yeah, because you would go, oh, okay, 132nd is really 6 squared on the bottom.
Yeah.
So therefore, I can bring that up as 6 to the negative 2,
You're kind of sunburned because of
and that makes it
second.
What if I was to give you, what have I not done here?
Yeah, boy.
What's another number? Log base 11 of the cubed root of 121. Erase.
The negative 6.
Okay, so that,
Got a negative 6.
oh, I got a headache.
Okay, are you buying what Casey said?
Yeah. 11
Yeah.
Yeah.
Because you know that's 11 squared.
Yeah,
So, 2 short?
And so if I can change that into 11 to the 2/3 power, I would have 2/3.
oh my God.
Did you see it before?
Never know what's gonna happen to this girl.
All right, now,
No, don't switch, I'm not ready.
I'm not ready to switch. Do you remember the two special kinds of logs that we use more than any other kind of log?
Natural and common law.
Yes. There are common logs and there are natural logs. Okay. Common logs always have what base number? Common are always base 10. Okay, why would 10 have been a really important base to use all the time?
Because it's simple to use.
How do we, when we change our, if you're working with,
Base we're on talking about.
okay, if Shannon does astronomy and she's talking about distances to the stars,
Well, that's
in millions or billions away, miles away, you're gonna change it into scientific notation times 10 to the whatever power.
Look at big number.
So,
That's because you beat
our number system is base 10. When we carry from the 1 to the 10 to the 100, that's powers of 10. So, therefore, base 10 was used a lot. And mathematicians are lazy. They didn't want to have to write the little 10 all the time.
Yeah, so it's even.
So they don't write anything. If you see a log with no base number, it's always base 10.
Yeah.
Your calculator, your log key on your calculator is base 10. That's what it's doing,
No,
base 10.
this one actually does.
Or does it?
Yeah, it
this
does.
one, does it automatically, or you don't have to set it, hit it every one?
No.
Okay. Okay.
So there's a way you can use.
Okay. Natural logs are what base number? E. The nature number. Okay, and once again, they didn't want to have to write base E all the time. And it's not I, it's L.
Oh, LN, okay.
It's LN. Okay, and to Simone, this would be normal, because it would be logarithm natural. We put the adjectives after the noun, so they did LN. Logarithm natural. We didn't invent it, honey. Get over your. this is long the math long ago. Okay, guys. Okay, so yes, your calculator does do logs. If you need to do a log that is something horrible, like base 73, and you need 15,968, these calculators automatically come up that way. If you press log, it asks you to enter the base, it asks you to enter the...
There's a way to do it without one thing, like, don't do that?
Okay. Your natural log key, though, if you want to do natural logarithms, do you see where... I guess I can pop it up.
Right next to the log. Come on, go back.
I'll go back in a sec. Okay, you'll notice you have, down here you have an e to the x key, and you have a 10 to the x key, and right above it, that's your log base 10 key, you got your natural log key. Okay, but you can get, am I on a calculation screen? I'm not on anything screen. So if I go say control 10 to the x and I tell it to put a log on, because we're now doing logs of all kinds, we're not nearly as dependent on base 10 logs as we once were because of the technology. You can put whatever base number in you want. If I wanna do 73, and I don't know what I said, 15,000,
15,968.
okay. You can ask it, it'll tell you. Now, will there be a section of this test where you have to do logs without calculators? Can you just always rely on your calculator? No. I will make you... Oh, yes, right, they don't, thank you, they don't work in press test, yeah. Thank you for remembering that.
We're at 15 and a half minutes.
Oh, thanks.